Hi all, welcome to channel again. In this video we will discuss about Aditya L1 mission. Aditya L1 will be launched through ISRO using PSLV rocket from Satish Dhawan Space Center, Sriharikota. The travel time from its launch towards the L1 point, that is Lagrange 1 point, is expected to be around 4 months, roughly around 4 months. After NASA, ISRO has taken a big step towards studying the sun, and obviously all other countries are now watching ISRO after successful Chandrayaan 3. So now the question is why to study the sun from, that is to from space, right? Let's have a look at sun and its activities before discussing Aditya L1 mission. About 4.5 billion years old star, the Sun, is the nearest star to the Earth and the largest object in our solar system also. Being the nearest star, studying the Sun in detail will provide us more information on solar flares, coronal mass ejection, solar wind, and different other things. If these solar flares, for example, if these solar flares get directed towards the Earth, they may cause disturbances in the near Earth space environment. The sun's core is having the temperature reaching up to about 15 million degrees Celsius. The sun's surface is also called as photosphere, is bit cooler, not cooler like a ice, but as compared to 15 million degrees Celsius, it's a bit cooler with a temperature around about 5500 degrees. The sun releases an immense amount of energy into solar system in the form of several harmful radiations and light obviously in different wavelengths. Now coming back to Aditya L1 mission. So the travel time from its launch point from this earth to the Lagrange point L1 is expected to be around about 4 months as I said before. ISRO is launching its first solar mission Aditya L1 to study photosphere, chromosphere and the outermost layers of the sun. Aditya L1 will be placed in a large halo orbit around the sun Earth Lagrange point L1. This is a point in space that is located about 1.5 million kilometers from the Earth. These points in space for a two-body system, such as Sun and Earth in this case, can be used by the spacecraft Aditya L1 mission to remain at these points with a reduced fuel consumption. As the spacecraft travel towards this Lagrange point L1, it will exit from Earth's gravitational sphere of influence as shown in the picture. It's a kind of pictorial representation that how this satellite will travel around the Earth initially and it will exit the sphere of influence and the cruise phase will start and subsequently the spacecraft will be injected into a large halo orbit around L1. The Aditya L1 mission will carry 7 scientific payloads instruments to conduct a systematic study of the Sun. With its placement in the Lagrange point L1, the spacecraft will have the advantage of continuously viewing the Sun without any eclipse or by affecting it to any other things. Aditya L1 mission will carry 7 scientific payloads instruments with it to conduct systematic study of Sun. 4 of the spacecraft payloads will directly view the Sun, while 3 other payloads will carry out in-suit studies of particles and fields at the Lagrange point L1. So just to have a bit of a better understanding, remote sensing payloads are those objects based on measurements made at a distance. Remote sensing is the science of making inferences about objects based on measurements made at a distance and without coming into physical contact of the sun. In-suit payloads are involved in detection of energetic particles in the solar wind or magnetic field measurements from a magnetometer. So now the question is why the Aditya L1 mission will be placed in L1, Lagrange point 1, between Sun and the Earth, right? The Aditya L1 spacecraft will be placed in large halo orbit around the Sun Earth L1 point. At the L1 Lagrange point, the gravitational pull of large two bodies, here the Sun and the Earth, equals the necessary centripetal force required for a small object to move with them, right? Here it is between Sun and the Earth. For any two-body gravitational system, here Earth and the Sun, there are total of 5 Lagrange points. There will be 5 Lagrange points will be denoted. That is L1, L2, L3, L4, and L5. When traveling towards the L1, the spacecraft will exit the Earth's gravitational sphere of influence. Finally, Aditya L1 will be placed in large halo orbit around the Sun-Earth Lagrange point. The L1 point is a stable location where the gravitational forces of the Sun and Earth balance each other out, as said before.